Okay, let's continue. So this is part 3 of problem 1414 and 1415. So we've just decided that the three females, their loci are linked. We know that the three females are this. There's the question now, are they X-linked or not? And this is where I disagree with the book. I don't think we can tell yet, but I'll warn you now, I don't see a way to distinguish X-linked or not, and I'll tell you why. Let's imagine this male. So X-linked or autosomal. Well, the interesting thing is that in the male, if it's X-linked, the male is hemizygous. So that's the obvious thing is, can we see a difference between the male being this versus the male being this? And the female is going to be the same, right? She's diploid in X chromosome, so we can't see that. Normally when we have this situation, we can see it because it's something like all the females are one way and half the males, or whatever, all the males, and there's some different ratio between male and female, and it's pretty clear. Here we don't see any difference between male and female in any of the crossings. However, because the male is homozygous recessive, and at the B locus and wild type, homozygous wild type, the other, it doesn't matter. He only produces one kind of gametes for females, so he only produces one kind of gamete either way except Y gamete. So we'd see that, and so maybe it'll show up, but in the O locus, the only one is wild type versus dominant. If there were recessive O locus allele, it would show up, but with a dominant O locus allele in this, I don't see how it shows up. The book explanation and the answer keeps on referring to some rule, but that's not an explanation. Okay, so I think it's not possible to distinguish it, and but let's just assume it's autosomal for the time, and I'll show you how I think about it later. Okay, so the question then is, which female is which? So let's consider the possibilities. So if one female is this, then and she's going to be crossed with the male who is this, then let's work out what the possibilities are. She can undergo crossing over, so she can make two parental gametes, and she can make it doesn't matter. She can only make two gametes, and he can only make one gamete, and what we expect to see is this genotype and this genotype, and those phenotypes are orange gray and red gray, and it doesn't matter if there's no crossing over. It doesn't matter, there's no possible crossing over. And if we look at this one, we see, okay, that would be this one, orange gray, and red gray, 50-50, and nothing in between. None of the recombinants, so only the parental. So this must be female 1. No, sorry, that's female 2. So this follows the pattern of female 2 here. Okay, so let's do the next one that we can. And now notice I'm not looking. So this is a problem-solving issue here. These videos are long, not to show you how long it takes to do the problem or how long it takes to understand how to do the problem or explain the problem or do it correctly. It's how long it takes me to explain how to do it and all the things that you don't want to do. And of course I'm going to talk about some biology on the meantime. um, notice that we could approach this by looking at 1, 2, 3 and trying to figure it out, and maybe this is what I did in recitation. Oh, can I tell what this is? Oh, can I tell what this is? That's not really the proper way to do it. Let's conceive of possibilities, and then let's see which one matches observation, right? We think of the hypothesis. Not that we don't look at the data, but we formally conceive of hypotheses and then subject them to this test, which is a prediction in this case. So this next one we'll do is in case she is in heterozygous at both loci, dominant and recessive, in a cis arrangement, in which case, and the male is the same. So she can make 2 parental gametes, and she can make 2 recombinant. So no recombinant in that one. And that means she can make then orange gray, or red with the black. So she would make these in different ratio, and we would see as a result, we would see this arrangement. And I have to make sure I'm talking, I have to make sure I'm not making a mistake. Plus B, this is all the same. And I'm doing the Punnett square on paper, not for you, I'm doing it for myself, right? I mean, don't think to do these in your head. You can maybe sometimes, but if you want to avoid mistakes, do it carefully. So what is this going to be? This is going to be orange black. This is going to be red gray. This is going to be orange gray. And this is going to be red gray, red black. Okay, so, and these two are going to be more common. These are parental, these are recombinant, and these two will be much more than the others. So orange black and red gray. Do we have orange? Where's orange black? Orange black and what are we saying? Orange black and red gray are common. So orange black, red gray are common, and orange gray, red black, orange gray, red black are uncommon. So that looks like female 3. This looks like female 3. Now I'm a little bit confused because when I did it before I came up with a different order, but I probably wrote them in a different order, so I'm not going to worry about that so much. Okay, so let's make sure the other one matches what we expect. So the next possible female, hypothetical female, would be this, and she can make her parental, this, and in recombinant. So she makes the same 4 gametes as the other one, but the cis-trans arrangement affects which are parental, which are recombinant, and therefore the ratio. So this, and this. So look, it's the same, but what's parental is different. What her parentals are her sisters recombinant, and vice versa. Okay, sisters are half-sisters. We don't know. And the male can only produce 1 gamete. So we have this plus B. And what do we see? We see orange. This is going to be orange gray. This is going to be red black. This is going to be orange black. And this is going to be red gray. Okay, that's different. Orange, black, red, gray, orange, black, red, gray. So what was parental and recombinant are reversed, and so we already identified 2 and 3. We expect her to be 1 then. So we see orange, gray, red, black as common. Orange, gray, red, black is common, the other 2. Okay, so now we've concluded that the females, what the genotype of females 1, 2, and 3 are. and we've addressed that. So now this is issue, let's see if I can finish in this video, of whether or not, I'm going to do something a little bit strange here perhaps. Let's consider hypothetically that that they're X-linked. If they're X-linked, the simplest way for me to do it is, so imagine that the male can only produce 2 gametes. So if that's the case, if the male can only produce 2 gametes, then all of these numbers that we are discussing would describe the females only. So now, here we don't see any difference in male and female. So my prediction would be, if this were X-linked, all the product females would be the same, and the males, therefore, well, would they be different? So instead of being, well, orange, gray, yes, red, gray, so the males would be the same as the females here. Do you see what I'm doing? I'm saying, imagine those are female, and then imagine what the males would be. The males would be just the gametes from the oocyte and the Y. And so orange, black, red, gray, orange, gray, red, black. So the male would be the same as the female here. Orange, gray, red, black, orange, black, red, gray. So I can't rule out X-linkage from this data. Maybe I can go, maybe I'm missing something here, because these 3 phenotypes, these 3 genotypes, could they have come from, I don't think so. So in this case, female 0, who we decided could be this and this only, because she has different fathers, she can produce, right? She can produce these 2 gametes, and with a wild type father, she could produce by crossing over this gamete, which depending with some father. So the ratio of the fathers, different fathers, would allow for these 3 daughter genotypes. So I don't understand. Oh, and by the way, did we figure out which is most likely? We don't know which arrangement is most likely for female 0, I think, because boy, let me see if I can do this in time. It doesn't show up here, and then we would have to know how many female type 1s, how many female type 2s, how many, so we'd have to have all the females here mated like this, and whether the male would survive that or not, a single male would survive that or not, I don't know. So we can't, I don't think we can rule out X-linkage. The book rules it out, and it doesn't explain why it talks about dihybrid test cross. This is not a test cross. Okay, I have to stop here and go to another